Hello everyone. Let us discuss about HTTP or HTTPS. In this video, we are going to know about application layer, protocol in application layer, HTTP or HTTPS, HTTP request message format, HTTP response message format. Application layer. This is the topmost layer in both the OSI and TCP or IP models. It is the only layer where a user can directly interact with the software application, that is, checking email, browsing the web, or video conferencing. The application layer is responsible for providing the necessary services to make all this communication possible. Specifically, it performs critical functions like handling user requests to access network services, managing the transfer of data across the networks, enforcing user authentication and security checks, and ultimately facilitating seamless communication between applications across the network. Protocols in application layer. The application layer relies on a variety of protocols to manage specific services. Here are 10 of the most common and critical ones. Firstly, HTTP, HyperText Transfer Protocol, and FTP, File Transfer Protocol. These are used for web and file transfer. Thirdly, SMTP, Simple Mail Transfer Protocol, MIME, Multipurpose, Internet Mail Extension, IMAP, Internet Message Access Protocol, POP3, Post Office Protocol 3. These are email protocols. Then DNS, Domain Name System, DHCP, Dynamic Host Configuration Protocol. These are used for naming and configuration. Telnet and SNMP, Simple Network Management Protocol, are used for management and remote access. Now, let's take a closer look at the protocol that powers the web, that is HTTP, and its secure counterpart, HTTPS. Both protocol operates based on the client-server model to facilitate communication over the internet. Communication always begins with the request sent from a client, typically your web browser, and ends with the response received from a web server. The critical difference between HTTP and HTTPS is security. Let's look at the side-by-side comparison. First feature is security. In HTTP, it is not secure and no encryption. In HTTPS, it is secure because it uses SSL or TLS encryption. Next, port. The port number used by HTTP is 80 and the port number used by HTTPS is 443. Encryption. Data transmitted in plain text. Here, data is encrypted during transmission. The speed in HTTP is faster and the speed of HTTPS is slower. Use case. HTTP is suitable for non-sensitive websites and HTTPS is essential for websites with sensitive data. Example, in online booking or e-commerce. SEO. In HTTP, lower ranking in search engines due to lack of security. In HTTPS, preferred by search engines. Google prioritizes HTTPS sites. HTTP versus HTTPS. This diagram offers a clear visual illustration of why HTTPS is essential for security. Look at the top scenario using HTTP. We seen Himani sending her password ABC123 to the website. Because of HTTP is unencrypted, her data is transmitted across the network in the plain text. This means that the hacker can easily intercept the data and read the password exactly as it was typed ABC123. This exposes Himani account to a serious security risk. Now, compared to the bottom scenario using HTTPS. Gaurav sends the exact same password, but because of HTTPS uses SSL or TLS encryption, the data is scrambled before it leaves his computer. When the hacker intercepts the data, All they see is a meaningless string of characters like XYA, ERX, ZABZ. They cannot decrypt this data without the proper key, which only the intended web server possesses. After seeing the security difference, let's summarize the 4 core benefits that make HTTPS a necessity for any modern website. Data privacy. The first major benefit is data privacy. HTTPS uses encryption like SSL or TLS to ensure that all sensitive information such as passwords, credit card numbers, and other personal details is protected from spying as it travels across the network. Integrity. Secondly, HTTPS provides integrity. It ensures that the data you send or receive is not altered or tampered with during transmission. If any changes are detected, the connection will be dropped. Authentication. Thirdly, we have authentication. HTTPS verifies the server's identity using digital certificate. This is crucial to prevent attackers from impersonating the legitimate site and stealing your data. It ensures you are talking to a correct website. Last, trust. Finally, HTTPS builds trust. Browsers and users alike trust HTTPS sites more. The familiar padlock icon in the address bar indicates a secure and reliable connection, which is vital for customer confidence and business credibility. HTTP versions. Let's look at the 2 primary versions and how they manage connections. Non-persistent HTTP, that is HTTP or 1.0. This is an initial version and is quite straightforward but inefficient. A new TCP connection is established for every single request or response pair. Once the server delivers the response, the connection is immediately closed. For example, imagine a browser requesting an HTML page that contains 5 separate images. The browser would need to open 6 separate connections, one for the HTML page itself and one individual connection for each of the 5 images. This overhead of constantly opening and closing connection significantly slows down web page loading. Persistent HTTP, HTTP/1.1. This led to the creation of persistent HTTP or HTTP 1.1, which is the version widely used today. In this version, the TCP connection is kept open and can be reused for multiple requests and responses. This change drastically reduces the overhead associated with opening and closing connection for every single resource. Using the same example, if a browser requests an HTML page with 5 images using HTTP/1.1, it can fetch all 6 resources, the HTML page, plus the 5 images using the same single connection. This feature is key to improving web performance and making the browsing experience much faster. Let's explore the format of an HTTP request message. This message is always sent by the client, usually your web browser, to the server to request a resource or to perform a specific action. For example, suppose you typed HTTPS or www.example.com into your browser. The browser automatically sends an HTTP GET request to the server, asking for that web page. This is the message component. An HTTP request is divided into 3 main parts: the request line, the header, and the body. Firstly, request line. This is the first line of the message and is absolutely critical. It includes 3 elements: HTTP method, request URI, and HTTP versions. HTTP method. This specifies the action the client wants the server to perform, such as get, post, put, or delete. Request URI. This is the specific path being requested from the server. For example, index.html. HTTP version. This indicates the version of HTTP being used by the client, such as HTTP/1.1. Example of request line: get/index.html HTTP/1.1. We move to the next component, the header and the optional body. Headers. The header provides essential additional metadata giving the server content about the client and the request. Key examples include host. This specifies the domain of the server the request is intended for, which is vital for servers hosting multiple websites. Example: host www.example.com. User agent. This contains information about the client itself, the web browser or applicable making the request. This helps the server tailor its response to the client's capabilities. For example, user agent Chrome/91.0. Accept. This header specifies the media types like HTML, XML, or images that the client is capable of receiving and processing. Example: accept text or HTML application/XML. Body. Finally, we have the body, which is the third component of the message. This part is optional and is primarily used when the client needs to send data to the server. It's typically included with post or put request to carry information such as data entered in a where form or the content of a file being uploaded. Together, the request line, headers, and body form the complete structured message that makes modern web application possible. After the client sends an HTTP request, the HTTP response message is what the server sends back in reply. This message contains either the requested resources, such as an HTML page, an image, or data, or an error message if the resource cannot be provided. Following our previous example, after the browser sends the GET request for http://www.example.com, the server processes it and sends back the structured response. Just like the request, the HTTP response is divided into three parts: the response line, the header, and the body. Response line. The response line is the crucial first line in the message telling the client what happened to this request. It contains three elements: HTTP version, status code, and status message. HTTP version. The version of HTTP the server is using, typically HTTP bar 1.1. This is the HTTP version. And status code, a 3-digit code that indicates the result of the request. For example, 200 means success, 404 means the resources was not found, and 500 indicates a server error. This is the status code. Status message, a brief, human-readable description associated with the status code, such as OK for a 200 code or not found for a 404 error. After the response line, which indicates the status, we examine the header and the body. Headers. The headers provide important metadata about the response and the server itself. This data helps the client process the response correctly. The key examples include content type, content length, and server and date. Firstly, content type. This specifies the type of content being returned, letting the browser know how to render it, such as text/HTML or image/JPEG. Content length. This specifies the exact size of the response body in bytes, allowing the client to know when the entire response has been received. Server. This provides information about the server software that generated the response, such as Apache or Nginx. Date. This indicates the date and time when the response was sent by the server. Next, moving on to the body. Finally, the body contains the actual content requested by the client. If the request was successful, this is where you find the HTML code for the website, the raw data in JSON format, or the binary data for an image or video file. Thus, HTTP and HTTPS together form the backbone of modern web browsing. Thank you.